All right, so a few notes on volcanoes. And this is chapter 7, roughly following along what you read yesterday and what we'll continue studying this week. So first, just really basic, and I think you guys all got this in the 60-second writing, but magma is melted rock, liquid melted rock that's under the surface, and so it's inside the crust. Ooh, an important detail you might want to write down. Next after this, we're going to talk about types of rocks. And if a rock is cooled volcanic material, it is igneous rock. But just to kind of connect to that, when the magma cools inside the Earth's crust, it's called intrusive rock. So we'll come back to that. This won't be on this week's quiz, but you will need to know this in another week or two. Inside, intrusive. And the common types of magma rock, the intrusive rock, include granite, which is interesting to me because I don't think of granite as being an igneous rock, a volcanic rock, but it is. Basalt, which is similar, but it's finer grained and black, and you find it underneath the ocean floor. And then there's crystals, it's solid, it's dense, and the bigger crystals are from it cooling more slowly. And in fact, in just a second, I'll give you some samples you can take a look at. And then lava, of course, is liquid rock on the surface of the Earth, right? This is the lava you've always heard about. It's come to the surface, and it cools there. It dries much faster than magma. It's less dense, lava rock. Extrusive because it has exited the crust. And then here are some great examples, and they have Hawaiian names, not too surprisingly. No, hang on, this is Pahoehoe, which is this nice, smooth, ropey looking lava rock. And then this one, which is pronounced A'a, which is pointy and sharp. So Pahoehoe, smooth and flowing, looks kind of like taffy. And then A'a is like pointy, and if you were to run across it in your bare feet, you would say ah, 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 right? Okay. Ah is what you yell when you run across the ah. So I'm going to show you a couple examples of this. Hang on a second. So as you look at the various samples of igneous rocks or lava rocks, one thing you'll notice is some of them have a reddish or pinkish color. The reddish or pinkish color comes from iron. All right, the textbook also talks about silica content. So the iron is what makes it red. The silica also has to do with how thick it is. So if it's really runny, like the Pahoehoe, it's going to have less of the silica, which is just another element. And the thicker that doesn't flow as well and gets pointy is going to be a higher silica content. Okay, and so that's, again, in a couple weeks when we talk about rocks and minerals and what they're made up of. That'll make sense there. Okay, also at the beginning of class, we talked a little bit about the types of volcanic eruptions. So there's two main types, and any one volcano can sometimes go through both types of eruptions. Whoops. So let's take a look here. These are types of volcanoes first and then types of eruptions. So first, there's three main types of volcanoes. And they're pretty easy because they're described basically by what they look like. So a cinder cone volcano is very cone-shaped like this, very triangular, very regular, and it's made up, cinders are just, loose rocks, like those really light lava rocks you're looking at, so cinders. So the cinder cones are pretty triangular, and they generally are just exploding out with these rocks. Does not have runny lava and does not have huge eruptions. And we'll look at a couple examples of those. Yes? That is the big island of Hawaii here. So for shield volcanoes, yes. For shield volcanoes, we have runny lava making multiple layers over and over and over again, making these low, flat volcanoes, right? Like this, just from years and years and years and years of eruptions. And this is the big island of Hawaii. And the crazy thing about the big island is this peak here, this volcanic peak, is actually over 14,000 feet high. And then this, of course, is sea level here. And if you were to measure this mountain from where it starts here all the way to the bottom of the ocean, where it technically started, it's way bigger than Mount Everest. But the strangest thing about this, when I went to the Big Island, you're driving around on this road and you're like, yeah, there's a 14,000 foot mountain. And you're like, well, where? Because here in Colorado, when we see our 14,000 foot peaks, they're pointy, right? Long's Peak. Those types of things are the 14,000 foot peaks. This is so gentle and low that you hardly recognize it as a mountain. It just looks like a plateau. And so it's a little bit, it's different than what we're used to seeing. Question? The shield volcano it has a low flat shape created by many layers of runny lava. Okay? And these pictures here are just pictures that I literally cut and pasted out of the textbook. So you should be able to find something like that in the textbook. And then the third type of volcano, maybe I suppose the most common type, is a composite volcano, which means it's made of layers of both kinds. And you also, the textbook and Brain Pop yesterday also called it a stratovolcano. Strato means layers. And so what happens here, and Mount St. Helens is a good example of this. See Mount St. Helens before it erupted, it's kind of lumpy. And so what happens is you've got layers of kind of lava eruptions and then explosive eruptions. And so you get a massively huge volcano. And again, we'll look at some other examples of these over the next couple days. Pyroclastic, so the two types of eruptions, a pyroclastic eruption, and I'm sorry, these are really tiny pictures. I guess you don't have your textbooks out. A pyroclastic eruption is going to be this huge, sudden, explosive eruption of gas and ash and superheated air. And so what's happening here, and this is a famous picture. This is, I believe, it's either Mount Etna or Mount Pinatubo. And what this is a Jeep kind of driving away from it, and this is the wall of stuff coming toward them. You can't outrun it. These guys had a pretty good head start. But what happened is scientists were monitoring this, and they knew it was going to go, and they were evacuating the airfield, and these are kind of some of the last people out. No, I don't think so. And so here also, over here, we see this one here is Mount St. Helens before the eruption and kind of during the eruption there. So you can see what's happening. The whole side of the mountain's blowing up, and all of that rock is going. And we'll look at some more pictures of that. Then the other type of eruption, kind of the more Hawaii type, and what Iceland usually does. Iceland is more, and Hawaii, it's this runnier lava. Oops, let's make this small again. The textbook either calls it a quiet eruption or an effusive. So you can remember it as a quiet. The more technical term is effusive eruption, but I don't think the textbook uses that. So that's kind of annoying. But yes, it's dangerous. Yes, you've got hot lava flowing, but the people in Hawaii, I mean, you just pick up and get out of the way. Yeah, unfortunately, your house might burn down, but not very many people are killed by this because it's constantly erupting, and generally, you know it's going to happen. Right, it's not the sudden, unpredictable thing that we see with the other ones. Okay, so runny lava, and this is, again, lower silica, and this kind of like little bit like what we're talking about with earthquakes. These ones are constantly releasing the pressure. So constant lava flowing out, as opposed to this where you've got gas and ash and water building up for maybe even hundreds or thousands of years, and then suddenly just massive explosion. Okay? And Mount St. Helens, we'll talk about a little more, is an awesome story, because basically what happened was scientists happened to be studying the area, the Olympic Peninsula in Washington State, and they said, you know what, we know that some of these are volcanoes, but as far as we know, they haven't erupted pretty much in written history. And in fact, there are some Indian stories of them erupting. So one of the universities said, well, let's study them. So they put a whole bunch of sensors on all of these mountains. And within 2 years of when they put sensors on Mount St. Helens, they started getting all of this little earthquake activity, and they started measuring. They could measure that in the side of this big mountain, kind of like this, there was this slowly growing bulge like this. And they could actually measure that it was bulging out like this. And then, yeah, on May 20th, 1980, what basically happens is this slides down and the side explodes out of the mountain. And some people died, not too many people. Basically, it was a big vacation area. It's like if people go up to, Estes Park or whatever. And they said, look, I don't care if it's the weekend, you can't go up because it's too dangerous. Some people who lived up there stayed up there anyways, and were never seen them again. There's also a couple of photographers who tried to get in close to see. I mean, close being like, miles away. But if you were, unfortunately, and they didn't know it was going to erupt out the side, right? If it had erupted out the other direction, it would have been much more devastating for like Seattle and those areas, but it erupted kind of to the northwest, which is more wilderness area. So we can look at that in a few minutes. But so those are our types of volcanic eruptions. The other really cool thing about Mount St. Helens is because they happened to be studying it, there's an incredible amount of detailed study on what was happening. And in fact, this picture right here, what this is, they were actually videotaping it, monitoring, and somebody was running their camera as it exploded. So there's a frame by frame, you can watch it frame by frame exploding. And yeah, I'll find it. I'm sure, I know I have it on a video, so I'll get that for you. But it's amazing that we actually happened to be watching it. And what they were doing is every day they'd take flights out in the airplane and go look at it. And so one morning they literally saw it happening, which is just insane that we're able to have that kind of information. Okay. So near Tokyo is Mount Fuji, which is a composite volcano. And is it going to erupt? It could. And there's a number of other ones. I mean, it's not in any imminent danger, and I'm sure it's highly it's highly monitored. I think this one is actually Mount Fuji. It's kind of unfortunate I don't have the names on this. This is Mount St. Helens after the eruption. So you can kind of see, it used to look like this, right? And now this is the crater, and it blasted out this side. And so there's some pretty good pictures of that. Oh, no, actually, you know what? This is Mount St. Helens before. So this is before, and this is after. And I'll show you in a few minutes, if you're interested in it, some things you can look. So here's, and this is Hawaii. And this is also showing a lava plateau, which is another way lava builds up. Here's this one again, Mount Pinatubo in the Philippines. Huge quantities of ash that rose high into the atmosphere and buried nearby areas. That one also, though, because it was being monitored, and I believe there was like a U.S., like an Air Force base or something there. And so they evacuated almost everybody. The only people left there were the scientists. And that's the scientists getting the heck out of there. And then this is cinder. Oh, this says it's a composite volcano. Now, I don't think anyone died in this one. Not the scientists didn't. That guy, you know what? I think that truck made it out, strangely enough. They were pretty close to the base. They were pretty close to the base when they took that picture. Okay. when Mount St. Helens erupted, so yeah, so it's like this layer, this amount of stuff covering everything. So imagine it's almost like having a huge snowstorm, right? Except that it's all ash and dust and rock and everything from like golf ball sized all the way up to, or all the way down to just fine particles, like we looked at in our little beakers here. And in fact, you know, this same kind of eruption covered Pompeii. Did anyone go see the Pompeii exhibit last year at the museum? So this is what covered Pompeii, a similar eruption of Mount Vesuvius. And so the whole town was buried. A whole town was buried in ash, and the people were killed not so much by the rock falling, but by the hot gases that they breathe in, and then it kills you. And it's a very famous firsthand account by, I think, Pliny the Elder. They were sitting there watching it happen and describing it. And some of them just didn't leave because they thought, hey, let's just see what happens, which turned out not to be such a good idea. Okay, so then this, guys, what's causing the earthquakes? And this is going to tie back into what we did last week. So volcanoes occur at plate boundaries, and they can occur at divergent boundaries. And this is, of course, like Iceland. And as, remember, there's lava, magma, lava coming up, making new crust and pushing outward. So this is a volcanic area, but you also have areas where it's building up into making volcanoes. Then the second type, you can actually have volcanoes occur at convergent boundaries. And this is going to be like Mount St. Helens. What's happening here, as this plate pushes down, it pushes down into the mantle and gets, basically, there's so much pressure, it melts, and that pressure, and then if there's water in the spaces between the rock, and so what happens is you get volcanoes here. So this is like what's happening along the Pacific Northwest coast. So you get volcanoes. And then the third type of volcanoes are a little unusual. They're called hotspot volcanoes. They're in the middle of a plate. And what happens, there seems to be, for some reason, a very active area in the mantle, and that active area in the mantle is causing the crust to melt, or maybe it's a weak spot in the crust, or maybe both. And then as the plate moves over this weak area, the newer volcanoes are here, so that'd be the big island of Hawaii. And then the oldest islands are way over here. And if you look at the Google pictures, there's more and more tiny islands all the way trailing out. So you can see evidence that the plate has moved. And the big island is, of course, still growing under the ocean on the, I believe, like the south side. So those are where we're having volcanoes happen. Then I believe that's mainly what we need to look at today. I will find a couple other things. This is some of the volcanic landforms that you're going to see in Thursday's assignment. So labeling the three types of volcanoes. And then you have other things like a lava plateau, which is exactly what it sounds like. And strange places you wouldn't really realize. Much of Idaho and Idaho and eastern Oregon and Washington State is actually a lava plateau. It's not active anymore, but it's volcanic. This is another very famous one. I'm just going to put this on this instead of making two lessons. Crater Lake, which is in Washington State. Crater Lake, you have a huge, what's called a caldera. A caldera, think of the word cauldron. Basically, a huge volcano has exploded and blown everything out and then collapsed. And then this is a little cinder cone volcano in the middle. If you've ever been there, it's a stunningly amazing place. And then it's filled with water because it's up in the mountains and it filled back up. Then, of course, Yellowstone is also a caldera, also known as a supervolcano. And will it erupt? Well, I'm sure it will at some point, and kind of hopefully not in the near future for us. Okay, so continuing through this last section, so different volcanic features. And again, you might be surprised, even around here in Colorado, we see volcanic features that you might not realize. Volcanic neck is the cooled main vent of a volcano, and I'll show you a picture of that in a minute, like Shiprock, New Mexico. A sill like a windowsill, is horizontal, and a dike is a vertical cooled lava. So this is a volcanic neck. Imagine, here's your huge volcano. This part of it is very dense, hard rock, and it cools. And then this other part erodes away, and you're left with this very big, tall magma thing. Have you ever seen anything like that? There's another famous one besides Shiprock, New Mexico. Devil's Tower in Wyoming is one of those. And so then a sill is when it's come up and cooled this way. A dike is similar to a volcanic neck, except it's a whole long ledge. And batholith is when a huge magma chamber has cooled, and that's Half Dome in Yosemite is one of those. So here's a few different things. So and this is actually Shiprock, New Mexico. And you can see it from I-25, you can see it from Mesa Verde, Colorado, you can see it from miles and miles around. And so you can tell this was once a huge volcano, and then that's what's left. And then you can see here's sills, and then a dike is a ridge like this, and that's a horrible picture. You can see it better in your book, but the resolution's really bad there. Then here is a dome mountain. So that was once a huge magma chamber that's cooled and everything else has eroded. And again, you can see areas here in Colorado or in the western United States that have areas like that. Okay, geothermal activity like Yellowstone National Park, that's happening because of magma underground, and the water heats and is forced out like a tea kettle boiling. In fact, in Iceland, that's how they heat many of their homes, is they run the water pipes under the ground, heat it from the volcanic stuff, and then use hot water heat for their houses. Okay. Oh my goodness. This stuff that's spit out of the volcano, pretty obvious, right? Ash, from dust-sized to pea-sized, right? Cinders, grape-sized to baseball-sized. Okay, that's going to start to get painful. And then volcanic bombs. Yeah, it is the coolest name. Volcanic bombs don't actually explode, but if you have a large basketball to Volkswagen-sized piece of magma, lava being thrown out of the volcano, it kind of may as well be a bomb, right?
Wait, Volkswagen, you mean like the big van?
No, more like a bug. Volkswagen bug sized beetle. Okay? And so you might think, why would anybody live near a volcano, right? Pompeii, why are you building there? Why are people still living there? Why are people living near Mount Fuji? Well, the reason why is all that volcanic ash and dust ends up making really good fertile soil hundreds or thousands of years later. And sometimes people might not even realize that they're living under a volcano, but it's really good soil for, grapevines and whatever you happen to be growing. Okay? Oh, and one last question somebody was asking. Oh, well, I was going to put that on the recording. There we go. A couple of sites that you can look on. First, you can just do Google searches for various volcanoes. You can go to, and we'll do this here in a minute, USGS, which is the United States Geological Survey.gov. And from there, go to earthquakes. And that's where we looked at before, and you could see like all the earthquakes that had happened in recent time. Somebody said, can you go there and see recent volcanic activity? I'm not sure, but I know the National Park Service in Hawaii, they have volcano cams actively watching Mauna Loa. So, it's through USGS. You can also just look at, it's actually called Hawaii Volcanoes National Park. So you can Google search that. National Park. And then, of course, Google Earth you can zoom in and see some pretty good images of things. So I will end this here, and then we'll look at some of those other things.